epidemic of unconsciousness. The main culprit, what physicians call deceleration injury. At a speed of just 35 miles per hour, a head can decelerate to zero in a split second. The results can be catastrophic. On impact, the brain ricochets within the skull, damaging the part of the brain closest to the point of impact and the part farthest away. Like all injured tissue, it begins to swell, a disastrous response for an organ confined by bone. Within the brain, billions of tiny calamities play out in that instant. Brain cells, or neurons, have thin tentacles that reach out toward each other. In a violent impact, these tentacles stretch and sometimes snap, spewing chemicals that they normally emit in small, regulated bursts. This chemical brainstorm only adds to the swelling. Pressure mounts within the skull, squeezing off the blood supply to the outermost layers of the brain, the thinking, feeling part of us, called the cerebral cortex. If the pressure rises enough, it will also begin to squeeze off the blood supply to the brain stem, the primitive core that controls our most basic life impulses, breathing, heart rate, temperature. And wherever swelling squeezes off blood supply, the brain begins to die, starved of fuel and oxygen. How much of the brain dies will dictate the coma's outcome. Unchecked swelling will kill both cortex and brainstem, resulting in brain death. Lesser swelling may destroy only the cortex and spare the brainstem, and the coma may evolve into indefinite unconsciousness. Swelling that subsides quickly enough will spare both parts of the brain, and the patient may regain consciousness.
Blood pressure was 98/68,